Okay, so in this video, we will be looking at how the derivative behaves over a product of two functions and a quotient of two functions. Let's start with the product. Suppose we ask, what's the derivative with respect to x of a product of two functions? Therefore, f of x times g of x. And what the product rule says, and again, the proof is in the notes that were distributed in class. And the product rule says the derivative of f of x times g of x will be the derivative of the first function, so f prime of x, times the second function, g of x, plus, and now we flip the derivative, so plus the first function f, plus the first function f, times the derivative of the second function, g prime of x. And that's the product rule, right? The derivative of f times g is the derivative of f times g plus f times the derivative of g. Let's look at some examples. So if we start with, say, the derivative of, let's start with 3x plus 4 times 2x minus 9. Well, we ask for the derivative of the product of these two functions. We can apply the product rule now. So we differentiate the first function, right? The derivative of the first function. The derivative of 3x plus 4, well, we have a sum of two functions, so we use the sum rule. Derivative of 3x is 3, plus the derivative of 4 is 0, so we get 3. Times the second function times g of x, so that's 3 times 2x minus 9, plus, and now we flip the role of the derivative, so plus the first function, so 3x plus 4, times now the derivative of the second function. The derivative of 2x minus 9 is just 2. And now we have the derivative. If we want, we can simplify the expression by multiplying through and regrouping powers of x and constant terms. So if we multiply by 3, and if you look at both terms here, there are no common factors. If there were common factors, we could pull them out and then multiply the leftover expression, but here there are no common factors, so let's multiply. 3 times 2x is 6x, minus 3 times 9, negative 27, plus 3x times 2 plus 6x, plus 4 times 2 plus 8. So what we have is 6x plus 6x, 12x, minus 27 plus 8, minus 19. And that's the derivative of 3x plus 4 times 2x minus 9. Let's do a second example. What if we look for the derivative? And now let's take a product of two quadratics. So say 3x squared minus 6x plus 1 times x squared minus, let's go with plus, 4x plus 3. So let's apply the product rule. We look for the derivative of a product of these two functions. So the product rule says derivative of the first function. Let's differentiate this one term at a time, right? The derivative over a sum or difference of functions is the sum and difference of the derivatives. So 3 is a constant multiple, it stays there. So it's 3 times the derivative of x squared, which is 2x, minus the derivative of 6x, this is 6, plus the derivative of 1, which is 0. And now we have the derivative of the first term times the second term, x squared plus 4x plus 3, plus the first function, so 3x squared, minus 6x plus 1, times the derivative now of the second function. the derivative of x squared is 2x from the power rule, plus the derivative of 4x is 4, plus the derivative of 3 is a constant, the derivative is 0. Let's see what we have. We have 3 times 2, that's 6x, minus 6, times x squared plus 4x plus 3, plus 3x squared minus 6x plus 1 times, times 2x plus 4. Now if you notice here, we're done with the differentiation. This is a derivative of this expression, but we can simplify a little bit. We can try and factor common terms. These are two quadratics. We don't have common factors, but here there's a factor of 2 that we can pull out, and same thing here. So this is 2 times x plus 2, and this one here is 2 times 3x minus 3. So we can factor a 2 from both of these terms, and this will give us 2 times 3x minus 3 times this quadratic, x squared plus 4x plus 3, plus this quadratic times, now we've pulled the 2 out, so we're left with x plus 2. So 3x squared minus 6x plus 1 times x plus 2. And here we factored all we could. There was a single 2. And if you look at what's left over, there are no common factors. 3x minus 3. You could factor a 3 from here as 3 times x minus 1, but it doesn't show up here. Same thing with this quadratic. So here you're left with multiplying out and then regrouping similar powers of x. It won't be pretty, but let's just do it. Let's multiply out by the 3x first, so we'll have 3x cubed plus 12x squared plus 9x minus the 3 minus 3x squared minus 12x minus 9. So that's expanding the first term, plus, let's expand the second term. So 3x squared times x plus 2 plus 3x cubed plus 6x squared minus 6x times x, 6x squared minus 12x. And finally, plus 1 times x plus 2 plus x plus 2. It's not pretty, but it's a cubic polynomial. Let's regroup powers of x cubed, x squared, x, and the constant terms. So we have 2 times, well, the x cubed, 3x cubed plus 3x cubed. That gives us 6x cubed. The x squared terms, 12x squared minus 6x squared is 6x squared, minus 3x squared is 3x squared, plus 6x squared plus 9x squared. Multiples of x, well, what do we have here? 9x plus x is 10x, minus 12x minus 2x, minus 12x minus 14x. And finally, the constant term, negative 9 plus 2, negative 7. So we now have the derivative of the original function, this quadratic times this quadratic, and we get 2 times this cubic polynomial. And you see the main work here was really the algebra. The derivative was quite simple. Derivative of the first function times the second plus the first function times the derivative of the second. And that is the product rule. In our next video, we'll look at the derivative of a quotient of two functions, and that's called the quotient rule.